So let's say in case A, we have 10 volts, and we have a resistance of 10 ohms. Okay, so I know Ohm's law, and it's V I R. Okay, since I'm looking for my I don't have my I. What is my I in this instance? Well, I would be equal to V divided by R, where my V is 10 volts, and my R is 10 ohms. So my I would be what? 1 amp. 1 amp, that's right. Okay, 1 amp. Now, let's go with case B, where we apply 20 volts. Well, now, I is going to be equal to 20 volts divided by 10 ohms. So I is now equal to 2 amps. Okay? With the same resistance. I'm pushing more. I have more push. Okay? I got 3 bouncers at the bar, and I got 3 dudes going crazy. All right, I still got 3 bouncers. Now I got 6 dudes going crazy. Okay, it's getting a little worse, right? Okay. So, what about in the other instance, where I begin to increase my resistance? Well, you can obviously see if I go to 10 ohms, then I'm going to go back down to 1 amp. Okay? What if I go to 20 ohms? Okay? So, first of all, what are we looking for here? Greg, what are we looking for? Looking for current, right? So I is equal to V divided by R. Now, let's go with our case of 10 volts. So we got 10 volts, and we've got 20 ohms, okay? So, Stephen, how much current do I have? 0.5 amps, okay? Now, is that our final answer? Right. That's right. Why can't it be 0.5? Megan? It's less than 1. And what is the rule for engineering notation? Justin? Must be between 1 and 1,000. Okay? So 0.5 amps, you must give the answer, Stephen said, of 500 milliamps. Okay? Now, very quickly, when we get into chapter 3, we're going to go into this may be 10 meg ohms, and this may be 10 kilovolts. Okay? So it's not going to stay simple very long. And we're going to need to know what meg and kilo and all that stuff is in order to give the answer. And the answer can't be 0.005 amps or, 5,000 mega amps and stuff like that. We got to get into this proper thinking. All right? So, we see here that if we increase our push to 20 volts, we double our current. Okay? Same amount of boulders in the riverbed, but more water has fallen in the lake, so the river flows more. But if we start dumping more boulders into our river, well, the current's going to have to slow down. Okay? Resistance is the opposition to current flow. Okay, here's your important information. Resistance is the opposition to current flow measured in ohms. Now, in the book here, I believe it gives even more information about what an ohm is. A resistance that develops 0.24 calories of heat with 1 ampere. You don't need to know that, but it's in this book. If you ever wanted to know it, it's in that book. Look how big that book is. Okay. So it's, let's see, the unit is ohm, and the symbol is R. Now, I'm not going to say, give me the unit, give me the symbol, and, just to trick you up, but I do want you to know that. Okay. Here's a basic symbol of a resistor. Okay, a little schematic symbol. We're going to look at some schematic drawings. Here is a carbon resistor. It's a 10-watt resistor. It can handle a lot of heat. It's got to dissipate a lot of heat. Got to have a closed circuit. If the circuit is open, there is no current flow. Okay, now, that sounds so simple. And it is, but here's the thing to remember.